applicability of Rolle's theorem to the function fx equal to x square minus 4 if x is strictly less than 1 and 5x minus 8 if x is greater than equal to 1. And the interval is given to us, the closed interval, that is in -2 to 8 divided by 5. So let's check whether Rolle's theorem is applicable or not. So this is the given function, and first condition of the Rolle's theorem is to check the continuity at x equal to 1. So limit x tends to 1 negative, that is all the values of x which is strictly less than 1, right, of the function fx. So this is equal to limit x tends to 1 negative. Okay, so this is x square minus 4, and then putting the limit we get 1 square minus 4, that is equal to -3. And now finding the right hand limit. So this is equal to limit x tends to 1 positive. And for the values x greater than 1, strictly greater than 1, we are taking this function. So when putting the limit we get 5 into 1 minus 8. So that is also equal to -3. So left hand limit is equal to right hand limit. Also, if I find f of 1, so this should be equal to, okay, for the value x equal to 1, again we have to take this function because this is for x greater than equal to 1. For the values of x strictly greater than 1 and also for the value of x equal to 1. So we are taking 5x minus 8, this function. So this is 5, putting x equal to 1 minus 8. So that is also equal to -3. So that means function is continuous at x equal to 1, right? So therefore f of x is continuous at x equal to 1. So if the function is continuous at x equal to 1, the same function is also continuous at all the points of this interval. Why? Because fx is a polynomial, right? Fx is polynomial, hence it is also continuous in this closed interval. Second condition, to check the derivability at x equal to 1. So for that, let's find out the left hand derivative of fx at x equal to 1. So this is f of x minus f of 1 divided by x minus 1. So this is equal to limit x tends to 1 negative. Okay, for x less than 1 we have to take this function first, minus f of 1. For x equal to 1, we have to take this function for x equal to 1. But when putting x equal to 1 over here, we get 5 minus 8. So that is equal to -3 divided by x minus 1. So this is equal to limit x tends to 1 negative. This is x square minus 4 plus 3. So that is -1 divided by x minus 1. We can make the factors in the numerator, that is x minus 1 into x plus 1 divided by x minus 1. So these two cancelled out, and now putting the limit x equal to 1 over here, we get 1 plus 1, that is equal to 2. So we are getting the left hand derivative to be equal to 2. And now finding out the right hand derivative. So this is f of x minus f of 1 divided by x minus 1, that is equal to limit x tends to 1 plus, okay. For the values of x strictly greater than 1, we have to take this function, and also for the value of x equal to 1, again we have to use this function to find out the value of fx at x equal to 1. So f of 1 becomes 5 into 1 minus 8, so that is equal to -3. So writing here -3 divided by x minus 1. So this is equal to limit x tends to 1 positive, and it is 5x minus 8 plus 3 divided by x minus 1, that is 5x minus 5 divided by x minus 1. And from the numerator I can take 5 common, so this is 5 into x minus 1. So these two cancelled out, and we are having this derivative to be equal to 5. And what is the left hand derivative? It is 2, and right hand derivative is 5. So that means left hand derivative is not equal to right handed derivative. So second condition of the Rolle's theorem is not applicable, right? So therefore, the function is not derivable at x equal to 1, where this 1 belongs to this closed interval which is given to us, right? So hence Rolle's theorem is not applicable for this function. Rolle's theorem is not applicable for the given function. Okay? Alright, thank you. Stay blessed.